Okay, in number 1, we need to be familiar with our definition of a derivative, and that's going to be on a sheet y'all got a little while back in class and we worked on. And because there's some variations in our definition, one thing to look for would be h approaching 0, especially in this type of format and this type of format, because that's going to be, h is going to be the distance between our 2 points, our secant points, or points on our secant line. So h has to approach 0, so notice that it is for 1, and it is not for 3. So I know I have to throw out 3. So if we're going to throw out 3, that's going to get rid of d, and it's going to get rid of e. Now, for our next one, this form right here is a very reduced down form. This is the function minus the function's value, and your function is getting super close to that actual function's value. So for this one, x approaching a is quite okay for that to be true. So that's going to be answer choice C. Now, still using that definition of a derivative, we need to try to interpret what's going on here. And this one is going to be very similar to the one that the limit as h approaches 0 of f of x plus h minus f of x all over h. Very similar to that. However, we know a for sure value for x. Notice that, and this next one is the function's value at x. So from this, it looks like x is going to have to be equal to e. So that makes sense because notice our function itself is the natural log of x. And so let's see, what would be f at e, just to make sure. The natural log of e is 1. So it makes sense that that 1 is sitting there. So this is asking for f prime at e, and our function itself is natural log of x. So f prime at e, natural log of x, that's going to be, well, that was strange. My pen went crazy. It's going to be answer choice A. Right, for number 3, it looks like we have a chain rule situation set up here. So let's go ahead and find our derivative. So h prime at x, it's going to be the derivative of the outside times the derivative of the inside. And now we want to know what h prime at 1 is going to be. So we're going to have f prime of g at 1 times g prime at 1. So g at 1 we see is 2, and f prime at 2 is negative 4. So we have negative 4 times, and g prime at 1 is negative 3. So that product is going to be positive 12. Right? Our next problem, this is going to be a formula. If we wanted the derivative of a raised to the x power, that's going to be the natural log of a times a to the x, and then times the derivative of x, which in this case is 1. So for this one, a is going to be 2, so we know we need at least the natural log of 2. So we know then these cannot be our answers. And then the rest of this we would have times 2 to the x, and then times the derivative of x, which is 1. So it looks like we're going to get answer choice C. And it's going to be the same for 5. If we want the derivative of the inverse of tangent, or arctan, inverse tan, then that's going to be 1 over 1 plus x squared. So notice that in place of x squared, though, we have an e to the 2x. So we know we're going to have at least 1 over 1 plus e to the 2x squared. And then we're going to have to take the derivative of just x. So the derivative here of e to the 2x is going to be 2e to the 2x. And so it looks like we're going to have answer choice B. Number 6 looks like we're going to have the product rule, and we do need to rewrite this to be x times 2x minus 3 to the 1/2. And so when we do our derivative, f prime at x equals, we're going to have first times the derivative of the second, so 1/2 times 2x minus 3 to the negative 1/2 times the derivative of the inside, and then plus our second, 2x minus 3 to the 1/2, times the derivative of the first, which is 1. And so now we have a place where we need to try to simplify and get as close as we can to an answer choice. So we are going to cancel out the 1/2 and the 2, and we know this is going to be x over 2x minus 3 to the 1/2 plus 2x minus 3 to the 1/2, and this is over 1. So it looks like our least common denominator is going to have to be 2x minus 3 to the 1/2. And a couple of ways we could do this. I would do our cross multiplication here. So x times 1 is x. Take whatever sign you have here in the middle, and then multiply these two. And when you multiply those, you add your exponents. So that's just going to give us a 1. So that's going to be 2x minus 3. And from here, I think we could pick out our answer. Notice we're going to have x plus x. So we need at least 3 x's on top. And the only one that's going to have a 3x, it looks like, is answer choice A. Number 7, we need to find the second derivative, and I would start out by rewriting this to make it just a little bit easier to work with. And the way we would rewrite this, we have y equals 2 cosine, and instead of x over 2, I would write that 1/2 x. And so y prime, your coefficient just moves down, and the derivative of cosine is going to be negative sine of 1/2 x times the derivative of 1/2 x, which is 1/2. And go ahead and clear up some of that before you do the derivative again. Notice you have y prime equals negative sine of 1/2 x. And again, that negative is just a coefficient, so it will be brought down to your answer. And the derivative of sine is cosine of 1/2 x times the derivative of 1/2 x, which is 1/2. So let's see, the correct answer in this case looks like it's going to be answer choice E. All right, our next problem, f is a differentiable function, so we automatically then know that we have a continuous function. So that's good for us to know. And let's go ahead and sketch out what we know. Let's go ahead and do just a rough sketch of that. We have the ordered pair 2, negative 5. So we have 2, negative 5. We have 5, positive 5. I'll put that up here at 5. And then we have 9 all the way out here, 9, negative 5. So it's on further down. Now, we don't know the shape of this, and we're always tempted to draw something that looks like this, and we don't know that that's what we're looking at. We could have something that looks just like this. So we have to be careful. Now, which of the following must be true? F has to have at least 2 zeros. Well, since we are continuous, yes, that one has to be true. We have to have at least one horizontal tangent. If we're told that we have a horizontal tangent, then that means that we had 2 y values to be the same. And notice we do have 2 y values to be the same, so a horizontal tangent is in the business here. And then for sum C, between 2 and 5, so let's look at 2 and over here at 5. So between 2 and 5, f at C has to be 3. So let's see, is a positive 3 over here. So let's check that one out and see. So this one looks like it's going to fit all 3. So here our correct answer choice should be E. All right, so moving on to our next problem, we are looking for the equation of the tangent line at these given points. So we have our equation of our tangent line, y minus y1, which is going to be 5, equals m. Well, we've got to find that m value times x minus 1. So now we need to find y prime and plug in 1. So we have the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Now we need to substitute in 1 and solve. And usually plugging in 1 hopefully is a little bit easier than the algebra. So y prime at, what were we doing at 1? So from our first parentheses, we're going to get a 1 times a 2 minus, plugging in 1 here, I'm going to get 5 times 3. And all of this is over 1 squared, or 1. So y prime at 1 looks like it's going to be negative 13. So let's go back over to our formula and substitute in negative 13. It also looks like they've done some rearranging here. So we have negative 13 times x minus 1. So let's see, y minus 5 equals negative 13x plus 13. And we would have to add our 13 over. So we're looking for a 13x plus y. And so it looks like B is going to be the only option. We will do number 12 in class, so we'll go over that one Monday in class. Moving on to our next one. Again, some more of the theory problems here. We have two functions that are differentiable everywhere, so we know they're continuous. If g is the inverse of f, and we know these informations, well, what is the derivative of that inverse? Well, let's see what it means to be an inverse, because that's going to help us solve this. If f and g are inverses, f of g of x is just going to be equal to x. They're inverses, they undo each other. So we need the derivative, so let's do the derivative of both sides. And this will be chain rule. We have the derivative of the outside times the derivative of the inside. And over here it's just going to be 1. So here's the derivative of the inverse. So g prime at x is 1 over f prime at g at x. So we want to know what is g prime at negative 2. Well, that's going to be equal to 1 over f prime of g at 2. So we're going to have to find, well, what is g at 2 going to be? Well, we see that g at negative 2 is 5. So what is f prime at 5, which is negative 1/2? So this is really going to be 1 over negative 1/2, which is the reciprocal of negative 1/2, which is negative 2. Okay, for our next example, we're given that this is the definition of a derivative, and we're saying that this is equal to 5. So we have a for sure derivative value. So in order for this to be true, f had to be continuous and f had to be differentiable. Now, is the derivative of f continuous at 2? Who the heck knows? We don't know that. So the only for sure statement we can make is Roman numeral 1 and 2. So we have answer choice C. For B, this might be a little bit easier for us to do if we rewrite this. F at x is equal to e to the x to the negative 1. So f prime at x, well, the derivative of e to the x is going to be your step prime. So it's going to be the derivative of x to the negative 1, which is going to be negative x to the negative 2 times e to the stuff, which is e to the x to the negative 1. So this should simplify down to be 1 over x squared times e to the 1 over x. So looking at this, it looks like we're going to have answer choice D. Part C, what is the instantaneous rate of change when x equals 2? Well, that's kind of a welcome question after a while, because that's just asking for the derivative value at 2. So let's find f prime going to be the bottom times the derivative of the top minus the top times the derivative of the bottom all over that bottom squared. And now let's substitute in 2. So it's so tempting to put an equal sign there at the end. Do not do that. Go ahead and work on that notation. We're going to rewrite this. So we're going to have, from the first parentheses, it looks like we're going to have 1 times 4 minus 2 all over 1. So it looks like we're going to have answer choice D. All right, so for our next problem, we're going to go through doing our derivatives. And so we're going to have f prime at x. It's going to be 4 times 2x plus 1 raised to the third times the derivative of the inside. And so that's going to simplify to be 8 times 2x plus 1 to the third. Now we're going to do our second derivative, which is going to give us 24 times 2x plus 1 raised to the second times the derivative of the inside. So that's going to give us 48 times 2x plus 1 to the second. All right, and now let's go ahead and do our next derivative, our third derivative. So the third derivative is going to be 96 times 2x plus 1 to the first times the derivative of the inside. Okay, and now finally our last one. So it looks like my pen stopped working, sorry folks. F, the fourth derivative of f is going to be here. If we multiply here and then there, we have our slope of our line, which is the same thing as the derivative, so it's going to be 384, which is answer choice E. Okay, our next problem involves implicit, so we're going to go ahead and do the derivative of tangent xy is going to be secant squared xy times the derivative of xy, and this is where our implicit is going to come in. So we have first times derivative of the second, so that's going to be our dy dx, plus their second times the derivative of the first, and all of that's equal to 1. And so we do need to do our distributive property, and this is where this is going to be a bit messy here. So we're going to have x dy dx times secant squared xy. We're doing our distributive property, plus y secant squared xy, and then that's equal to 1. And we need to solve for dy dx, so we're going to have, and we can do all of this in one step, I believe. So we're going to have dy dx equals, and in the numerator we'd have 1 minus y secant squared. To slide my board over, minus secant squared x, 1 minus secant squared x, y, there we go, divided by x secant squared x, y, okay, and now let's see if we can't match our answer choices. And I'm going to run out of room here. We'll finish simplifying this one in class tomorrow. Remind me that we got right here, and we will finish this out. It will eventually simplify to E, but it's going to take a lot of steps to get there. All right, let's look at F. We've still got our implicit differentiation, and we are going to go through here and do our first derivative. So we're going to have 2x plus 2y dy dx equals 0. And through some algebra, we're going to have dy dx equals negative x over y. And now we need to find that second derivative's value. So we're going to go through and do our second derivative. And we're going to need to do our quotient rule. So we're going to have bottom times derivative of the top minus the top times derivative of the bottom. And that's all going to be over a bottom squared. And now we're going to continue working through. So here, well, there's no need to simplify this up. Let's just plug in our value. And so we've got our second derivative. Need to pay attention to the problem a little better. We're evaluating this at 4, 3. So we're going to have negative 3 plus 4 times, well, dy dx at our point is going to be negative 4/3. So we're going to plug in negative 4/3. And that's all over 9. Now we're going to have to do some simplifying here. So we're going to have negative 3 minus 16 over 3 all over 9. And so that's going to be negative 9 minus 16 all over 3. And all of that's over 9. So we're going to have negative 25 over 3 times 1 over 9. So it looks like we're going to have negative 25 over 27, which is going to be answer choice A. All right, for our next problem, we have that the derivative of f of x is greater than the derivative of g of x. Graphically, all that means is f prime of x is y values are higher than g prime of x's y values. And so what could be true about the graph of y equals f of x and g of x? They couldn't intersect more than once. They might intersect once, but no more than that. All right, so for our next problem, we have this line here is tangent in the first quadrant to the curve of blah, then K is. Key word here is tangent. When you see that word, you need to think slope and derivative. And a quick way to find the slope of this line is going to be what I just drew. So it's negative 3 over negative 4, so the slope is positive 3/4. And so when we find our derivative over here, so that we're tangent in the first quadrant to this curve, then K is equal to what? So let's do our derivative over here, and we see that we have y prime equals 3x squared. And so let's set 3x squared equal to 3/4 and see what happens. So we have 3 over 4 has to be equal to 3x squared. And so we're going to divide both sides by 3. And so notice that x squared is equal to 1/4. So x is plus or minus a half, but we're in the first quadrant. So that means we're going to have answer choice A.